Hello, it's pleasure to welcome you for my mathematics class. Today I'll be handling one Boole's inequality and another a problem in random variable. This is a basic problem, but this is being often asked in university examinations, and that this basic knowledge can only carry you to higher level of doing problems in the probability and also in distributions, and it plays an important role. The basic things must be properly understood, then only you see that you will be able to understand and do better in your higher level of probability problems in probability theory or in distributions. Okay, now I will just first do this Boole's inequality. This is Boole's inequality. This states that if a1 comma a2 dot 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 an or events, they are simply events, they are only events, then it is probability of conjunction of 1 I is equal to 1 to n of this is greater than or equal to I is equal to 1 to n probability of ai minus n minus 1. Call this as your 1. So this is what I am going to prove. I will straight away go into the problem, that is proving the inequality. So let a1 and a2 be two events. Let an1 a2 be two events. Then we know very well that P of A union A2 is equal to P of A1 plus P of A2 minus P of A1 intersection A2. This is your addition theorem. This is your addition theorem, and that you must know that the sum of the probabilities is always equal to 1. Let there be n number of events happening, but the sum of the probabilities of all these will be equal to always 1. So you see that, so this concept will naturally imply that P of A1 plus P of A2 minus P of A1 intersection A2 is less than or equal to 1. It can be at the maximum 1. It can be 1 or less than 1. So this will simply imply that P of A1 intersection A2 is greater than or equal to P of A1 plus P of A2 minus 1. Call this as your 2. I have not done anything except that algebraic, that is taking the terms to the left hand side and right hand side. Thereby I am able to get this result, and you call this as my 2, and you see that now you just view this 2 with 1 here. You see that in this particular case you have taken n number of AIs, that is the even n number of events are there, but here you see that there are only 2. In fact, you can put it like this. I will write this as, see, it can be written as See, it is P of, it is like this, P of conjunction I is equal to 1 to n of AI. This is what I have written here. So if you take it in this way, it is P of A1 plus P of A2. Then here it is n minus 1 means put n is equal to 2. So you will get 2 minus 1 is 1. So you see that this is true. Therefore, this implies, I'll write it. 2 implies that for n is equal to 2, 1 is true. Okay. Now for n is equal to 2, if you take n is equal to 2, that is only 2 events, you see that this 1 is true. Now I will prove this inequality using mathematical induction. What is mathematics? See, it is the method of mathematical induction in the sense that, let us see, for example, if you take like this, let me not go deep into that. If a situation comes, I will teach you very elaborately about what is mathematical induction. But here I will just tell you what is mathematical induction. See, mathematical induction means, you see that here I have assumed 2 events. So A1 and A2, for the 2 events, this inequality is true. So let me now assume that this is true for some number n is equal to r. R is a positive number. Try to understand that all are positive. So for some number n is equal to r, you see that, let me assume that this one is true. And if I can prove that for the next immediate r plus 1, this is true, means my problem is solved. That means if I can prove that, I assume that this is true for r, then if I can prove for r plus 1 it is true, means for any value of n, whether it is r plus 1 or r plus 2 or r plus 3, this inequality is true. Therefore, this inequality is true for all values of n. So this is called the mathematical proof by mathematical induction. Are you able to understand? Okay, now let me assume. So assume that sigma of here I will put it like, assume that for n is equal to r, 1 is true. This implies, that is, I will write here, that is P of conjunction I is equal to 1 to r, ai is greater than or equal to this I is equal to 1 to r, it is P of ai minus r minus 1. Call this as your 3. So you see that I will assume that this is. So if it is assumed that it is up to r, this is true, means this is valid. Now let us prove that for what? R is equal to n, n is equal to r plus 1. If I can prove that this is true, then my problem is over. So let me write here, okay? Now let me take this. Now, say I'll write it here. Now, see, I will put it like this. Now, conjunction of I is equal to 1 to this ai. This you write this as, this can be written as P of intersection of conjunction of I is equal to 1 to r, ai intersection ar plus 1. So this is, after all, what is the meaning of this? Ai means, see, the meaning of this is, it is P of a1 intersection a2 dot 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 intersection ar conjunction ar plus 1. So this is the meaning of this. Now up to this you write like this, and ar plus 1 comes here. So this is what is the meaning of this. So you see that I split it up into and write like this. Now you see that you can view this as your A, call this as your A, and call this as your B. Now you see that I can use this proof. That is, if there are only two events, then this 2 is true. So you take this as A and take this as A. So naturally it means that this is nothing but your P of I is equal to 1 to R AI, then plus P of AR plus 1 minus 1. Why that is so? So I told you, I gave an explanation. How do you get this? Here you see that P of A1 plus P of A2, it is nothing but your sigma of I is equal to 1 to n. So this is also like this. If you want, I can write this as, this means that it is P of, it is like this, P of conjunction of I is equal to 1 to 2 of AI is greater than or equal to sigma of I is equal to 1 to 2 of P of AI minus 1. So the same as this, these two are same. So you see that I can write it in this fashion. So you see that here you consider this as your A and this as your B. So applying 2. So using 2. Applying, see, using 2. So using 2 I am writing like this. Then you see that this will be again greater than or equal to. You see that this can be written as sigma of I is equal to 1 to R P of AI minus R minus 1 plus P of AR plus 1 minus 1. This is using 3, because as per our assumption this is what we are having here. So in this place you are justified to write this result because that is our assumption. So this will be greater than or equal to, you see that this is I is equal to 1 to R P of AI plus P of AR plus 1 minus, so you see that it is minus R plus 1 minus 1. So this is what you are having. Now you see that therefore, so this is what I am having. Therefore I can write in this place. See here I will write here. So you see that here, so this is what we are having. So this one, so what is the result that we have to prove here? So prove that P of conjunction of I is equal to 1 to n AI greater than or equal to sigma of I is equal to 1 to n P of AI minus n minus 1. So this is what we have to prove. So this is what we have to prove. So I will write in this place, prove. This is what you should prove. Prove. So you see that this can be written as greater than or equal to, combine this is up to R, this is R plus 1. So you can write this as I is equal to 1 to R plus 1 minus plus 1 and minus 1 goes off this R. So you see that if it is R plus 1, it is R, because R plus 1 minus 1. If it is R plus 2 minus 1 will be R plus 1. So you see that this inequality is valid for all values of n. So this, see, this shows that, so for n is equal to R plus 1 is proved. Therefore 1 is true for all values of n. That's all. So this is what we are having. So you see that first you just take 2 and show that the inequality is proved with that. Then you assume that it is true for r up to n is equal to r. Then prove for n is equal to r plus 1. Then it means that the inequality is true for all n. So that is what I have proved. This is an important one, and you can just take this and this is proved. So this is your HT, hence the proof for this. So this is what we are having. Now let me come to this this one, the second problem here. Let me like this. Yes. Now you see that it is given that x is a random variable. By random variable, I simply mean I conduct one experiment in which you get yes, the sample space. You define a function x from s to set of all real numbers. So you conduct one experiment in which the outcomes, the exhaustive outcomes are taken in the sample space. You define a function. So random variable is a function x from s to set of all real numbers such that x of lambda belongs to r for lambda belonging to s. And you see that this is called a random variable, and x is a example I will give you. See, you see that I will put here, you just take this as here HH, HT, TH and TT. So you see that x is a random variable that takes HH to 2, and it takes, here you see that x is a random variable that takes this to 1 and this takes to 0. What is this? X is, I tossed a coin twice. A coin is tossed twice, or 2 coins are tossed, no problem in that. See, when both the coins turn up head, then you see that you get 2 hits. And if one is head and other is tail, or the first one is tail and another head, again you see that it results in only one head coming. And if both are tail, it means that no heads come. So you see that I represent this, that is the various outcomes in a distribution, that is probability distribution table. So what I do is, say this 2 coins are tossed, 2 coins are tossed, we get, see, x is a random variable, x, and x can take the value 0, x can take the value 1, or x can take the value 2. Here 0 represents no h, that is TT. Here 1 represents TH or HT, and this one represents your head. You see that, therefore, there is a possibility of TH coming or HT coming. In both the cases, only one head is coming. But in this case, 2 H's come, and here no H come. So these are the only ways. Now you see that probability of x. See how many, what is your sample space now? Your sample space is equal to HH, HT, TH and TT. Now you see that you want the probability of HH. What's your probability of HH? So it is probability of 2, that is equal to 1. See, n of s is equal to 4. So your favorite set is HH. It is having only one element. So you see that if you take this A, so let me not elaborate on that. So you see that 2H is equal to 1 by 4. So probability of 2H, see probability of 1H, see HT or th, that is equal to probability of 1, that is equal to, actually it is 1 by 4 plus 1 by 4, that is equal to half, and probability of 0h, that is equal to probability of 0, that is equal to 1 by 4. So you see that these are the, so you see that what is the probability of getting HH? TT is 1 by 4 and this is half and this is 1 by 4, and we find P of Pi of, see it is like this, sigma of I is equal to 1 to n Pi xi is equal to 1. That is, here see P1 x1 is what? It is 1 by 4. I will write it here, P1 of 0 plus P2 of 1 plus P3 of 2 is equal to 1 by 4 plus half plus 1 by 4. So you see that the sum of the probabilities in anything, suppose if another example is you toss a coin, you see that you will get 6. That is, if you toss a die, you will get either 1 or 2 or 3 or 4 or 5 or 6 points coming on the faces. Now what is the probability of getting each face? It may be 1 or 2 or 3, whatever it is 1 by 6 chances. That means the chance of getting, the probability of getting every face is 1 by 6 chances. So that phase may turn out to be 1 or 2 or 3 or 4 or 5 or 6. You see that? So you see that you can, so here you see that the random variable x, so it takes what? It may be 1, 2, 3, 4, 5, something like that. Okay. So these are some examples. So I am not going deep into that. I want to do this problem. So I am giving you a broad idea about what is a random variable. And that here I want to mention only this. That is, if let us suppose that, I will just tell you here, I will give an example and tell you. See, let us suppose that here there is a 1 kilometer distance is here. 1 kilometer distance you have got here, and you are going for a sightseeing. That is, you are going to visit mountainous area, and you see that you can continuously from 0 to 1 you can see the pleasant things, that is the natural beauty, all continuously you can see. But you see that you have got certain places in the middle, like this place 1 plus 2 plus 3, which are all called beauty spots, or it is the tourism place. So you see that you can stay here. So there are finite. So you have got only 3 places where it is called the exclusive places of visit. Can you understand? These 3 are exclusive places of visit, whereas you have got continuously you can go and enjoy the beauty of nature. Can you understand? So here you see that the random variable, see this is called a random variable. Random variable takes the values 0, 1, 2. They are finite values. Finite, here you see that it can visit 1, 2, 3. So the values of the random variable is finite or countably infinite. It can be countably, there can be any number, but it is countable. So there can be, so if the random variable takes finite number of values or countably infinite number of values, then x is called a discrete random variable. See, x is discrete random variable. And you see that here this is a discrete random variable. Here also this is a discrete random variable. Whereas in this case, if you are going to completely go through, completely see on your way everything and go up and up, you see that it is a continuous one. That means your probability, that is your random variable, takes infinite continuous values. So you see that here it is continuous. It is between two, it is an interval or between two limits. So you see that it may be 0 to 1. Here you see that 0 to 1 kilometer distance. So it is a continuous one. So since it goes continuously, you see that here x random variable will be it is a continuous random variable. It is x is a continuous. continuous random variable. And if it is a continuous random, if it is a discrete random variable, you go for algebraic summation. Can you understand? No, that is algebraic summation. If it is going to be a continuous random variable, it is an integral summation. Can you understand? So integral summation means use integration to get the value of the values of the some of the probabilities. But if it is a discrete, just algebraic sum will give you. So this is the difference between a discrete random variable. Discrete random variable is a random variable which takes finite number of values or infinitely countably infinite number of values, whereas in the case when it is a continuous random variable, it takes continuous values which may be defined in an interval. It may be an interval. Can you understand? So these are the things. This is just an example. You can give any number of examples. Practically you can experience and give examples like this. So let me stop with this and come to this problem here. So you see that in this problem you find it is a discrete random variable. So this is a discrete random variable, and because x takes the value, see what are the values that x takes? X takes the value, x is a random variable, it takes the values, some events are happening and the events are mapped onto 0, 1, 2, 3, 4, 5, 6 and 7. And you see that the values, the probability of x is equal to x. Probability means the probability of the chance of getting 0 is 0, chance of getting 1 is a, 2 is 2a, 3 is 2a, 4 is 3a, 5 is a square, 6 is 2a square and 7 is 2a, 7a squared plus a. Now here we will start answering the questions one by one like this. See, you have got like this. So let me answer the questions one by one. So you see that what is the value of this a it is given. Let me now take this. So what is the value of this a? I will just, these are not required. Now I'll put it like this. So what are the values of? To find, see, first one is to find a. You know how can we find a? See, we know that I have taught everything to you. So we know that sigma of pi xi I is equal to 1 to n is equal to 1. Pi of xi. Here p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5, 6, 7 is equal to 1. That is, now you substitute the values here. So when you substitute, here you just, I don't want to waste my time on this, because you can understand here, this is 2, 4, 7, 8, 8 plus 1 is 9. So you see that 9a plus 7 plus 2 is 3, 3 plus 10 is 10a squared. What? So 10. So this implies 10a squared plus 9a minus 1 is equal to 0. Now factorize this. So this implies 10a minus 1 into a plus 1 is equal to 0. So you just see that 10a squared minus a plus 10a plus 9a is equal to 0. So this implies a is equal to 1 by 10 or a is equal to minus 1. So you see that when you put a is equal to minus 1, it doesn't suit, and also you must know that the probability can never be negative. That is, probability is equal to what? P of a is always greater than or equal to 0. P of s is equal to 1, where s is the sample space, and that you see that if a and a intersection b is equal to null, P of a union b is equal to P of a plus P of this. So this is your Kolmogorov definition of the probability. So you see that always it has to be greater than or equal to 0, and that also you must know that it is 0 less than or equal to a less than or equal to 1. That means it can be at the maximum 1, but at the least it must be 0. So you see that this is what we have. So from this So it is we cannot accept this. So A is equal to 1 by 10. So this is my probability. So you see that A is equal to 1 by 10. So the first problem is over. The first problem is over. Now let me go to the second one. Now what is your second one now? See, second one is, what is the P of, to find P of x less than 4. See, x less than 4 means this is nothing but what? It is, understand that P less than 4 means P of less than 4 means, see, if you have less than n, suppose if you have less than n means, this means that P of x is equal to 0. If you have a 0 plus P of if you want, whatever, if you want, you can write, no problem. X is equal to 1 plus dot dot dot, it goes up to x is equal to n minus 1. That means what? It will not take the value n, but it will stop before this. So using this idea, what is that you'll have? P of x is less than 4 is equal to P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3. Don't take this 4. So this will be equal to what? P of x is equal to 0 is, you can write this as also P0 plus P1 plus P2 plus P3, that is equal to 0 plus this is 5, 7a. Up to 3 I want 5a. 5a. So that is equal to 5 into 1 by 10, that is equal to half. So you see that this is equal to your half. So the second problem is over. Now let me go to the next one. So what is that? If you want, you can write this also here. See, it is like this. 0, 1, 2, 3, 4, 5, 6, 7. Anywhere you can write 1, 2, 3, 4, 5, 6, 7. So you see that up to this you have got, see, Px less than 4 means up to this you have got. So up to this the probability is found to be half. Okay, now you want, what is that? P of x is greater than or equal to 4. Here greater than or equal to 4 means you have to take this 4. So this is equal to x is equal to 4 plus x is equal to 5 plus x is equal to 6 plus x is equal to 7. So you see that this can be written, or the same thing can be, whole of this is 1, probability is 1. See, it is probability of x less than or equal to 7 is equal to 1. If we take the full probability, it is 1. So it is 1 minus this one. So P of x is less than or equal to 3. Up to this 3. So you see, subtract, you see that 1 minus, what is your 3 or less than 4. You must put either less than or equal to 3, or this is same as telling it is 1 minus P of x less than 4. Less than means 4 means don't take 4. So less than 3. So this is 1 minus. So you have got this half, that is equal to half. If you want, you can just try this. See, what is here this one? So what is your P of x? X is equal to 4. What is P of x is equal to 4? 3a plus what is your x is equal to 5? A square plus this is 2a square plus 7a square this. So you see that 3a plus this is 4a plus 10a square, that is equal to 4 into 1 by 10 plus 7 by 100, that is equal to 40. This is what you have. Say 3a plus a square plus 2a square plus 7a square. So how much do you get here? 2a square, 7 plus 2 is 10. This one 1 plus 3, 1 plus is 4. Now you have got this. So what is that you are having? It is 7a square, 10a square I will put it like this, 10a squared. I will rewrite this 4a. This is 3a plus a, 4a plus 10a squared, 4 into 1 by 10 plus 10 into 1 by 100, that is equal to, you will get it as it is 5 by 10, that is equal to half. So you see that whether you do like this or 1 minus of this, you are getting the same answer. So this is equal to your half. Then what is this? So this is over. So this is over. So you see that either you can go by this and write, or you can just do like this also. But in many cases you have to take only like this, because writing, finding the values, sometimes it will become very, very tedious. Very, very tedious. It all depends on how many events are left out, whose probabilities are given. It all depends on that. So accordingly you can use this idea. So this is the idea. Now, so here what I have now, let me go to the next one. So let me go to the next one. So what is this? Next is, see, what is P of x? So for what value of k, for what value of, find the value of k, see, x is greater than half. Here you are given, see, P of x is less than or equal to k and it is greater than half. The question is, for what value of k this will be greater than half. That means you see that, see, P of x is less than or equal to k is equal to half. Find k. Now what is that you will do here? See, you will just try numbers here. Suppose we have found, see, we have already seen up to 4. You see that you only when you get 4, when you get x is equal to, when you get k is equal to 4, now from 1 we find when k is equal to 4, P of see, or we will write like this. What is your, we will straight away write this. Now what is your P of x is less than or equal to your 3. Can you see this? Less than or equal to 3 or less than 4. So this we have found it to be what? So this is nothing but P of x is less than or equal to half. So you see that this is equal to half. So when k is equal to 3, you get it equal to, this is equal to half. But you want, for what value of k, here what value of k, this will be greater than half. I mean this. For what value of k, this probability will be greater than. If it is k is equal to 3, the probability is half. So naturally, only when k is equal to 4, your probability will be more than half. Can you understand? So you see that here you are asked, if see, if P of x less than or equal to k is greater than half, find the value of k. See, we have already found P of x less than or equal to 3, or this is as good as saying P of x less than 4. It is found to be half. So you see that if you take k is equal to 3, it is equal to half. But I want that value of k for which it is more than half. So this means that k must be equal to 4, so that P of x less than or equal to 4 is greater than half. Correct or not? What is your P of x greater less than or equal to 4? What is your P of x less than or equal to 4? That means you must go up to this. So a, 3a, 2a, 2a, then 4, 8a. So you will get it as what? 8a, that is equal to 8 by 10. So it is 0.8, and 0.8 is greater than half. Can you understand? So for what value of this? Therefore k must be equal to 4, so that your probability will be more than half. Can you understand? So this is what you, and understand that P of x is equal to k means at the point k. probability at the point k. If it is P of x less than or equal to k means the probability, sum of the probabilities up to k. And if you have it as P of x greater than or equal to k means the probability, sum of the probabilities more than of all the events more than k and more than k. So that is the meaning of that. So I have finished this also. Now you see that we can find what is the cumulative probability, that is cumulative distribution function. This is called cumulative distribution CDF. CDF is defined as fx of x which is equal to P of x less than or equal to x. So this is the definition of this. So and very simple things I will tell you. Fx of infinity is equal to 1. Fx of minus infinity is equal to 0. Minus infinity means understand that what is the meaning of this? P of x is less than or equal to minus infinity. And you see that the probability can never be negative. Therefore, this is 0. But if you take fx of infinity means what? It is going up to cumulative up to infinity. So this will always be equal to 1. Now that means what? You cumulate. You add the probabilities one after the other up to a point. It is stated here. It is stated here up to x means stop at x and find out the sum of the probabilities up to x. And can you understand? So this is the meaning of this. That is why this is P of x is less than or equal to x. Now let me do this. See what is that we are having here. Let me start doing this. So fx of 0. What is the meaning of this? P of x is less than or equal to 0. See, x is less than or equal to 0 means what? Here x is, these are all, I don't want all these things. So let this be here and let me here, this is 3. This is 3. See? What is the probability? X is equal to less than or equal to 0 means up to 0. So you see that the probability of here, probability of x is equal to x is 0. Then fx of 1, P of x is less than or equal to 1. So you see that P of x is equal to 0. This is P of x is equal to 0 plus P of x is equal to 1. Okay, now this is equal to 0 plus 1 by 10, that is equal to 1 by 10. So you see that up to this it is 1. That means probability of this plus this. Cumulative. Can you understand? And what is your fx of 2? That is equal to P of x is less than or equal to 2. That is equal to P0 plus P1 plus P2. That means 0a plus 3a. 3a is equal to 3 by 10. So this is 3 by 10. So you see that. Then you see that fx of 3 is equal to, it is P of x is less than or equal to 3. That is equal to P0 plus P1 plus P2 plus P3 up to 3. So this will be equal to, see, a 3 means what? 2 by 5. So this is 5a, that is equal to 5 by 10. So you see that this is your 5 by 10. Then fx of 4. So this is equal to P of x less than or equal to 4. P0 plus P1 plus P2 plus P3. Okay. 1 means this, 2 means this, 3 means this, 4 means this one, P3. Here 3 means 4. So you see that this is equal to 4. So this is up to 4. So 3 plus 2, 5, 5 plus 2, 6, 7, 7 plus 1 is 8. 8, and that is equal to 8 by 10. 8 by 10. See, I will put it here. Then fx of 5, P of x less than or equal to 5, P0 plus P1 plus P2 plus P3 plus P4 plus P5. Now that means what? Up to this is we have got 8a, and you have got a square, that is 8 by 10 plus 1 by 100, so this is 81 by 100. So this is 81 by 100. Then fx of 6, p of x is less than or equal to 6. So this is your p0 plus p1 plus p2 plus p3 plus p4 plus p5 plus p6. So up to this we have found 81 by 100 plus add this is 2 into, it is 1 by 100. So this is 81 by 100 plus 2 by 100, that is 83 by 100. So this is 83 by 100. And what is your f x of 7, that is equal to p of x is less than or equal to 7, p0, p1, p2, p3 plus p4 plus p5 plus p6 plus, say accumulate. Up to this it is 83 by 100. I accumulate now. Plus this is how much? It is 7 by 100 plus this is 1 by 10. How much do you get here? It is 7. Okay, this is 83. Now you see that 7a squared. 7a squared means it is 1 by 100. 7 by 100. This is 1 by 100. So you see that how much do you get here now? It is 2a squared is 83 by 100. So you see that this is 83 by 100. What is your 7a squared? This is 1. So you just multiply this by 100. So you see that this is equal to 17. This is 100 by 100. So this is 100 by 100. That is equal to 1. And fx of infinity is equal to what? It is more than 7. Actually speaking, this is fx p of x greater than or equal to 7. For 7 also it is 1. So this is always. So for all these values, here afterwards 1 only. From this it is up to. So you see that cumulate. You cumulate everything. So here you see that these are all cumulate. So this is 1. So you see that here. Now if you want the individual probability, this minus this will give you f of 1. What is f of 2? This minus this. 2 by 10. Can you understand? 2. Probability of 2 minus probability of 1 will give you this. Probability of 3 minus probability of 2 will give you probability of 3. Probability of 4 minus probability of 3 will give you this. So you see that individual probabilities can be found. This is called your cumulative distribution function. Okay. Now, so this is all about your this one. This is a simple problem, but as I told you, these problems will form the basis for your understanding the higher levels in probability theory. So I will be doing more problems in the coming days. Thank you.